Okay, good morning, afternoon, or evening, everybody. Welcome to the Improve Airborne Data Discovery and Access with Toolsets for Airborne Data webinar. This is your host, Jennifer Brennan. While everybody is logging in here, you'll see two optional polls located at the bottom left and middle portion of the page, and we do appreciate your feedback on these polls. They help us to continually improve upon this webinar series. I've got 2 p.m. Eastern Daylight Savings Time, so let's go ahead and get started. First, what I'll do is I'll start off by reviewing a couple of housekeeping items related to this webinar. To ensure best audio experience, the conference has been placed in silent mode. However, if you have any issues or you have any questions, what I'd like for you to do is enter those into the Q&A pod located on the lower right-hand corner of your screen. This works like a chat. The webinar will be recorded and will be posted both to our, I should say, it is being recorded and will be posted both to our online Adobe Connect webinar catalog as well as to our NASA Earthdata YouTube channel within a couple of days of completion. And I do plan to provide the URL to all of you at the end. All presentation files will also be available for download at the end of the webinar. As far as timing is concerned, today's webinar will be 1 hour long. We've allocated 45 minutes to the presentation and live demonstration with an additional 15 minutes for the question and answer period. After our speakers have finished their presentations, what we'll do then is we'll move to a final set of polling questions. And from there, we will transition directly to the Q&A period. You will have an opportunity to ask your questions throughout all portions of the webinar except during the live demo by using the Q&A pod. And again, this works like a chat. Questions will not be answered using the raising hand function. It has been disabled. One final note, depending upon the volume of questions that we receive, we will extend the Q&A period an additional 15 minutes to 3:15 p.m. for those of you who may wish to stay on the line. Before I go over the agenda today, I'd like to introduce our two speakers. Our first speaker is Amanda Early, who is a programmer analyst at the NASA Atmospheric Science Data Center Distributed Active Archive Center, or ASCC DEC. Our second speaker is Aubrey Beach, who is a User Requirement Systems Engineer at ASCC DEC. Let's move next to the agenda here. I'm going to pull this up for you. During today's webinar, Amanda will begin with an introduction to the ASCC DEC, Airborne Data, and will provide an overview of the tool sets for airborne data application. From here, our second speaker, Aubrey Beach, will transition to a brief TAD architecture overview followed by a live demonstration for the TAD application. And then finally what we'll do is we'll talk about some of the future enhancements you can expect to see to this tool suite in the future. With that, it is my pleasure to introduce our first speaker today, Amanda Early. Amanda?
Thanks, Jennifer. Good afternoon, everybody. Just wait for the slides to start loading. There we go. So, as Jennifer mentioned, I'm going to start off by briefly discussing the ASCC DEC. The ASCC is one of 12 NASA DECs located in Hampton, Virginia, so right down here. We specifically specialize in 4 fields, which are radiation budget, clouds, aerosols, and tropospheric chemistry. Apart from that, we also assist in the archiving and distribution of airborne data. And as the topic of this webinar is the toolsets for airborne data, that's the bit that we're going to be discussing. TAD, the short name, was developed at the ASCC to provide users with enhanced airborne data discovery and analysis. Moving on, I'm going to discuss a little bit about what TAD actually is. The toolset for airborne data, again, TAD, was developed by the ASCC as a way of meeting user community needs for manipulating aircraft data for scientific research and on climate change and air quality relevant issues. This came about due to the fact that NASA has conducted airborne tropospheric chemistry studies for about 3 decades, and these field campaigns have generated a great wealth of observations. So TAD came about in order to help users to deal with this data. What you can see here is just a basic diagram of the TAD system. It includes both current aspects and future enhancements. Some of those enhancements will be discussed a little bit later on. So what you can see here is we start off with the actual data, and then that is brought into the ASCC through our data ingestion system. Once it's at the ASCC, we can actually start putting it into TAD. Here. The user is able to access TAD via the user interface, which will be shown a little bit later. But specifically, they can go through and put in search parameters in order to discover whatever data they would like from the original information. And then the system will create output files that will then be given to the user. We'll, again, discuss a little bit more about this later on. That's just a basic overview of what TAD is and does. Here you can see our TAD data holdings. Most are currently in TAD. A few of these will be in the future. At the moment, we have 8 NASA and NOAA campaigns. Most of those are legacy data. However, we do intend to add more recent missions as the data becomes available from the ASCC. So you can see these first 8 are what we currently have. All right, moving on. What I'm going to discuss now is a little bit about the actual airborne data, and specifically why you should consider using it and how TAD will help you along the way. So we have just a bit of background on actually what the airborne data is. Aircraft measurement of atmospheric trace species can generally be classified in 2 ways, as either remote sensing or in situ measurement. An in situ measurement typically just involves the collection of an air sample through an inlet mounted on the side of the aircraft. The air sample is then analyzed by instruments aboard the aircraft. TAD is only focused currently on in situ observational data, as that represents the majority of airborne measurements in the atmosphere composition focus area. In situ data from recent studies are reported in what is known as the ICART file format, which is an ASCII data format and is a NASA standard since 2010. What you can see here are just a couple images from one of the more recent field campaigns. So here you can actually see the inlet mounted on the side of an aircraft. And this is one of the instruments from aboard that aircraft as well. So the data will go in here and be analyzed here. So why should you actually use airborne data? There are a number of advantages to this type of data. For example, you have a high spatial and temporal resolution. You'll get a large number of simultaneous measurements, much larger than what you would get from space and most ground-based long-term measurement sites. All of these measurements are great for characterizing specific atmospheric processes, and they can often be used as benchmarks for assessing and evaluating both models and satellite observations. So it can be used in a lot of different ways. That being said, while it is great type of data, you actually do need to be able to understand the data in order to use it. So for the next few minutes, I'm going to discuss the ways that TAD can help you as a user to understand and use the airborne in situ data. Well, TAD takes care of many of the computational aspects of parsing the data. This can actually be challenging for a user to deal with themselves as the ICART format. While easy to read since it is ASCII, it can be difficult to parse since its format isn't as strict as you may like. For example, it does have a lack of units or descriptions on many of the variables. It allows for special characters and comments, and often the delimiters will be inconsistent. So going from one mission to another, you may have trouble parsing delimiters. So what you can see here is an example of part of a header from one of the original PI files. And you can see that it is lacking descriptions down here. You just see the units and the variable names. That's one of the issues that TAD helps to fix. And TAD helps to deal with these issues in 2 different ways. First off, we have something that we call the idealized ICART format, which is essentially just an adjusted format of the actual ICART file format that has stricter formatting guidelines. This is something that is strictly internal to the TAD system, but makes it a lot easier for the system to pick up on the data. The second thing we use is a comprehensive metadata database, which is an SQL relational database that links high-level campaign information to the lower-level PI variables. So I'm going to just discuss the idealized iCard format briefly. Really, the difference between this idealized format and the actual iCard format is just that we use stricter formatting guidelines. So for example, the idealized format requires units and a descriptive long name, which you can see down here. This is the exact same format, the exact same header. However, now we have the units and the descriptive long names on every single variable. We also require consistent delimiters throughout the file, and we require that start, stop, and mid-time for all data intervals be reported, which will make for easier analysis down the line. I'll come back to that a bit later. Our metadata database, like I said, links higher-level campaign information to the individual variables. So what you can see here, these are the lower-level variables. They are linked to the mission itself, the specific flights, the PI from each of the instruments, the data ID, which is just a descriptor for the instruments and the types of variables, and the individual files. And these are all linked together so that the system can search more easily. All right, so once you're able to parse the files, you come across the issue of actually discovering your data. This can pose a problem simply because each campaign is generating hundreds of variables at the same time, and across field campaigns, the variable names may not be consistent. So what you're seeing here in this diagram is just a very small subset of the available variables for 3 different missions. You can see that even just in that small subset, there are going to be a lot of variables. So in order to find what you need a way to search each of the campaigns together. TAD assists in this by using what we call a common naming system to link the variables across campaigns and help to improve data discovery. This system was developed for TAD to access the variables across all missions, and it helps to handle the inconsistent variable names in the existing PI files. Our system has 6 high-level groups with various subgroups based on chemical and physical properties of the measurements, and it was developed in communication with the Global Change Master Directory, also known as GCMD, to maximize consistency. The trace gas groups, which I'll show you in a moment, were modeled from the GCMD structure for gas-based species. And the goal of this was to cover the most extensive list of current airborne in situ measurements. If needed, as campaigns continue to go on, we add to this list. And this is a diagram showing each of the high level and their sub-levels in the common naming system. You can see we have 6 high levels: aerosols, meteorological and navigational, trace gases, cloud properties, J values, and radiation variables. Some of these, particularly these 3, have lower sublevels, and then some of the sublevels have lower sublevels. The individual common names fall into each of these categories. So to really understand why this system is so important, what I'm showing now is an example of a single common name. A common name shown in the middle is dew point, and you can see that for each of these missions in the green, and each of the platforms, which is the aircraft in the blue, you may have a completely different name for that same exact variable. For example, you can see here that on Texas AQS mission, dew point is called dew PT temp PDL _F, whereas the exact same variable on Intex DC8 is known as DP cryo. So if you were attempting to search for dew point just by the PI names alone, you might have a bit of an issue finding it. TAD allows you to search for that dew point common name, and that will provide you with both options. The last aspect of TAD that I'm going to describe is how it allows a user to actually analyze the data. And what you're seeing here in this diagram is the data for 2 variables from different instruments on the same flight. As you can see, the data is not measured on the same time scale. Now, this is very common from amongst the flight. Now, for example, navigational data is always going to be reported at a 1-second interval, whereas from the WAS instrument, you might see it at a 60-second time interval. This and the fact that location data, meaning latitude, longitude, and altitude, is typically only reported in a single navigational file for each flight, rather than with each variable individually, can make analyzing the data from different instruments a bit challenging. So in an effort to simplify this process, TAD allows users to create a time-based merged data file, which is essentially just a geolocated data file. And so you can see here, is the original PI data from the previous slide, which has been merged in here to exist on the same time scale. To give you an idea of how this is done, this is an example of a single merge interval with some PI data around it. So right here you have one merge interval and then four PI variables, four PI variable data points. And each of these is looked at to see how much of the PI data interval overlaps the merge interval. As you see, we have two that are completely overlapped, one that is partially overlapped, and one that is not overlapping at all. The one that is not overlapping will not be taken into account at all. For the others, what we do is calculate a weighted average based on the amount of overlap between the two time intervals. And that will output a single interval on the merge interval timescale. CAD does specific averaging for scalar variables, vector variables, wind direction variables, and data flags. Obviously, this is just a very basic explanation of how that's done. If you want to get a bit more information, see the URL at the bottom of your screen. Provides our documentation, which includes detailed information on how this process is done, including all of the equations for the calculations. TAD allows users to obtain merged data with a few different options. You will always receive the weighted average, what I just discussed. It is also possible to receive standard deviation and the number of points, original data points per merged time interval. When available, we also provide uncertainty propagation and limit of detection propagation. Output will always be a single iCart file for each flight. And we provide two possible merge interval options. The first is a continuous time interval, so that's what you can see up here. I believe these are 60-second time intervals, or the time intervals from a data ID of a selected variable. So here, the blue data has emerged in the time intervals of the green data. And that's just going to give you a basic idea of what TAD is and how it can help you with aircraft data. So to go over the actual user interface, I'm going to turn you over to my colleague Aubrey Beach, who will tell you a bit more and provide you with a live demo.
Thanks, Amanda. Oh, go back one. So for my part of the presentation, I'm going to give you guys a brief discussion on the design overview of TAD and actually do a live demonstration. So for the first part, the development of the application, we're leveraging open source libraries with PHP on the back end, jQuery, JavaScript on the front end, alongside a Postgres database, which is, again, all open source. And this really allows us to create a unique experience on the client side for performance optimization. We're not having to hit the database every time. This is available, you can use on all major browsers. And we've implemented Eosys Earthdata login, which allows us to just quickly process orders, and takes about 2 minutes to sign up. So you can just create an account and access the platform. So just to give you guys a brief overview of the user interface before we start the live demo. The first section I want to kind of showcase here is the basic search. This basically is divided into a couple of different filters. So the first being a global search. If you're a more experienced user and you know exactly what variable of interest you'd like to go for, you can type it in here. You can type in the chemical makeup or the actual name of. You can actually filter by mission and platform, or by the flight date range. The second thing I wanted to show you is the search by category, which is more of a faceted search. And this is going to allow you to actually open up each of these sub-levels and review variables hidden within each level. This third area is the variable selection. So based on the filters from these first two areas, you're able to take a look at variables of interest and make your selections by simply checking them off. Again, these are going to be the common names, and below, you'll see the actual PI variable names alongside descriptions and the more information about each of these variables, like instruments, the data ID, units of measure, platform and mission. Just a little bit more on the actual faceted search. So again, I referred to the fact that you can type in a keyword. And what is that keyword? What are we actually searching for in the database? So we're looking at the common name, PI variable name, an alias of that variable of interest, because different user communities might refer to the same type of variable in different ways. Common naming categories, definitions, and descriptions. And I'll showcase this in the demo. But we also allow you to define a search pattern, so you can refine this to specifically a chemical property, or you can see if this chemical or variable of interest might be contained within something else. From a technical standpoint, we are just pulling down that data one time and allow you to search locally from the browser. We're not having to continuously hit the database, so that just basically equals better performance optimization. The search by category, again, this is the faceted search that Amanda touched on, but we allow you to expand and collapse each category so you can look at different variables of interest. So for here, I've shown how trace gases is broken down into sublevels, so carbon, hydrocarbon, down to alkalines, and this will allow you to easily start filtering variables of interest. So I'm going to go ahead and start the live demo of TAD. You guys can follow along. The address here is tad.lark.nasa.gov. And with that, I'm going to switch over to the live demo to the login screen. So again, this is the main login screen for TAD. We have a brief description about the project. And the Earthdata login process, again, takes 2 to 3 minutes to sign up. It's going to allow us to seamlessly send you any orders you place right to your email address as soon as they're processed. So along the top here, I want to first point out that we have extensive documentation, about 32 pages if you really want to get into the weeds of the entire application. So we refer to the metadata database, how we actually perform the merge equations. So if you really want to get into some of the complexities and kind of really see how we're putting all these weighted averages together, feel free to take a look at the documentation. We also have a video tutorial at the top. So this is on YouTube, and you're able to just kind of have a quick walkthrough of how to use the platform. FAQs, so if there's any trouble, you're waiting for an order, we answer some common questions here, and who to contact if you have any follow-up questions or comments. For each mission, we also have broken out mission page for each. So we have a brief project description, relevant links about that mission, and we have flight dates that you can take a look at, along with flight tracks, which are static right now. They're static PDFs, but that's one of the enhancements that I'll touch on a little bit later in this demo. And just to round it out, these are relevant links to some of the other agencies and sponsors that we've been working with. So just to start out, again, this is the exact user interface I was just showing on the slides, but we have, at first we have the global search, which is going to allow you to type in any type of variable and start filtering. So For example, I can put in formaldehyde, which is CH2O. You'll notice that the variable selection here has automatically started filtering down the selection. Now, some user communities might put in formaldehyde as HCHO, which you'll see is also compatible and will pull similar types of results. The reason that the first thing that I typed had additional things here is that formaldehyde might be found in some of these other variables, but again, you can use this interface to really narrow down your selection and define a search pattern. You can filter by mission and platform, and we will actually go ahead and filter down which platforms are available as you select different missions. And you'll notice here on the right as well, the date range will actually update based on flight dates that are available during that time range. So I'm going to go ahead and select a couple of these variables. I'm going to go ahead and clear out global search just to quickly show you guys the faceted search here. So if I'm not as experienced of a user where I might be able to immediately define a variable of interest, I can search by category where I'm looking at the physical and chemical properties. So for example, trace gases, as I kind of referred to in the presentation, I can go down and I can open up different sublevels and look at variables of interest this way. You'll notice that this is updated based on my selections here as well. To just kind of quickly recap as well, these common names, I'm going to go ahead and just type in the formaldehyde one more time so go ahead and showcase. So you'll see here that we have CH2O, and then I've selected a couple of different, while I've selected these and they all appear similar up here, you can see that the PI name, the variable name, differs or is different based on the PI submitting the data, and that is one of the biggest purposes of having this common variable naming system, is that it's going to allow you to look for these different variables across missions that would otherwise be harder to understand when you're looking at it from PI to PI. So the main concept of this tool at this point is allowing you to create merge data. So hitting that button at the top or any of these tabs, you can actually go ahead and proceed with your order. Again, these are broken out by mission and platform, so you can simply open these accordions and place separate orders. This gives you a chance to refine some of your variables that you selected previously. You can select a merge time base, so that can actually be based on the data ID above. So you can select a data ID. You can see the PI associated along with data source description. But you can also input a custom merge time base, anywhere between 1 second and 1 hour. So go ahead and put 60 seconds. Now, an optional configuration allows you to select specific flight dates or flight ranges. If you don't make a selection here, we'll just give you the entire flight track, the entire mission. And then we give you 3 different processing options: average only, average with standard deviation of number of points. And just to quickly show, there's these tooltips that allow you to get more information about each of these different output options. The last being number of points with limit of detection processing. So at this point where I've really defined my order, I can go ahead and hit order merge data. You'll get a confirmation, and then you'll get 2 different emails, the first being successful receipts of your order, and followed by a actual FTP link once your data order has been processed. And the ordering times may vary. It really depends on how many variables have been selected and some other factors, but generally these arrive within 10 to 15 minutes or so. Just to showcase another component of the tool sets for Airborne Data, we also allow you to pull the original PI data. So I can go ahead and compare my custom merge data with the original PI's data if desired. You don't have obviously as many options, but you can go ahead and, again, you can refine variables of interest, select flight dates, and order the raw PI data that has not been altered. So with that, I'm going to go back to the slides to discuss some of the future enhancements of TAD. So we are beginning a 2-year effort on these enhancements under the name of Subsetting Tools for Advanced Analysis of Airborne Chemistry Data. So some of the major features that we're going to focus on include spatial subsetting. So as you kind of saw from the current user interface, unless you're a more experienced user, you might not know where a mission took place. What we'll be doing with the spatial subsetting is allowing you to just interact with a global map where you can draw a bounding box, and you can obtain data from within the selected region from multiple different flights and just kind of see what data is available in that specific geographic area. Another big feature that we will be working with is the vertical profile subsetting. And this is going to allow you to select data from a specific vertical profile and provide a lot of information on the spiral, such as average latitude and longitude and maximum minimum altitude. So some of the proposed user interface enhancements, overall, we really want to simplify the initial search. So whereas now you currently have a couple of different ways immediately as you start using the application, we're going to allow you to kind of really pick which way works for you to start your initial search. That's going to be, the spatial range, temporal range, the variable type, and also if you are familiar with that field campaign, you can go ahead and specify it immediately just to start filtering down your search. And it's going to be more of a guided wizard approach to really help you through the entire ordering process. So with that, any contact information, again, I'm Aubrey Beach. My email is right there. You can contact Amanda Early as well, and our PI or principal investigator that we've been working with, Dr. Gao Chen. With that, I'm going to turn it back over to Jennifer and start the Q&A.
Okay, thank you, Aubrey. Thanks, everybody. We have finished a little bit early today, but now what we're going to do is actually move to our final set of polling questions. And generally what I'll do for this is give them, 2 or 3 minutes or so. So I'll probably give it 3 minutes, and from there we'll transition directly to the Q&A period. And so, be sure to stay on the line and or stay in the meeting room to participate in the Q&A. All right, thanks everybody. So we'll just give these 3 minutes or so and then we'll move forward. This is really great feedback, everybody. We've got about another minute left for the polling questions, and then from there we'll move directly to the Q&A portion. All right, everybody, let's go ahead and move to the Q&A portion of this webinar. And the first thing I would like to do is draw your attention to the lower right-hand corner of your screen. What I've got there is I have today's presentation both in PDF format as well as PowerPoint. So if you're interested in downloading the presentation for today, what you would do is you would left-click on any of the files, and you would then be prompted to download that file. Okay, and I've also uploaded the agenda to the SharePod as well. And to the left, you'll notice that you've got information about connecting with us as far as social media is concerned, and then the webinar will be posted to the tinyurl.com Earthdata webinar, and then also on our YouTube channel. All right, so let's move first to our questions. The first question that I have, Aubrey or Amanda, is how many files can you order per order? So either one of you want to tackle that question?
Sure, I can take that. We don't actually have a limit on the number of files ordered, but it depends on the actual mission and platform. So as Aubrey showed in the demo, we split up the orders by the mission and platform, and you'll get one file for each flight that you select. So if you select a range of dates with 5 flights, you'll get 5 files for that order.
Okay, great. Thank you, Amanda. Do we have other questions? Give everybody a second to think about this. Any other questions from anybody?
So while there might be a couple of other questions, I just wanted to briefly just kind of mention that we are actively working to incorporate some additional data sets in the near future. From one of the slides earlier, you can go back and see some of the more recent field campaigns like Seekers, Discover AQ, Colorado, California. Those are going to be available in the near future, and those are some of the, including some of the enhancements and everything that I went over. We're going to be really trying to expand the array of airborne metadata that we have.
Okay, thank you, Aubrey. So in that vein, do you have a more defined time frame for when the Discover AQ, for example, data products will be added?
Right now we have a couple of different things just because of this new proposal that we have where we're really mocking out a lot. We're in the requirements and development phase, so it's going to take us a little bit to really put together a level of effort on that. But that's something that if anybody's interested in a specific field campaign, feel free to reach out. We can try to give you more clarity on when we think it might be released.
Okay, thank you. Are there any further questions? Okay, great. Are you considering to add data averaging and binning tools by spatial or altitude range?
By spatial range, yes, that's some of the stacked enhancements that we're discussing in the future. I do not believe we are planning to bin it, however. The current plan is just to be able to pull out data from a specific spatial range and adjust that by altitude.
Okay, does this answer your question, Frank? Okay, great. Are there any additional questions? Okay, the next question is, okay, yes. Are the PowerPoints available for download? Yes, they are. So if you look down in the lower right-hand corner of your screen, you should see what is called within Adobe Connect a file sharing pod. And if you, hover over any of these file names, we've got the agenda, and then I've got the PowerPoint, as well as the slides prepared in a PDF format, just in case. And you'll click on it, and you should then be prompted to download the file. And I should also mention this is a persistent feature. So were you to access the webinar recording by way of our online catalog that you see located, the link, the tiny URL link to the left, you'll still be able to download the files at any later date. We've got archived webinars dating back to the end of May 2013. So we focus on a different data access or data discovery tool or suite of data products every month. So you may be interested in checking that out. And indeed, there have been many other webinars from the ASCC Deck as well that you could find on there. Are there any additional questions? If there are no additional questions, then what we'll do is we will log off from the telecon portion of this webinar. And I'd like to leave the virtual meeting space open an additional 10 minutes or so for those of you who may be interested in downloading the presentation files, or if you think of something as you're getting ready to log off, you can type it in there. Thank you very much to everybody for participating today. Our next webinar will actually be held on, we've got a 3-day online Giovanni workshop, which is focusing more on the Giovanni tool for geoscience education. And that's in November 15th through the 17th. And then after that, we will have a webinar on November 21st that will focus on NASA's socioeconomic data, specifically remote sensing derived environmental indicator data products. Okay, so stay tuned to that. If you sign up to our listserv, you'll receive an announcement for upcoming webinars. Again, I thank everybody for participating today. I thank our speakers, Aubrey and Amanda, and I hope that we will see you at an upcoming webinar. Let me just do one more check to make sure I haven't missed anything at all. Let's see here. I don't think so. All right, well, thanks everybody. At this point, we will log off from the telecon portion of the webinar, and I'll keep the virtual meeting space open if you think of anything.